All right, kids, since the other video ran a little long with the notes, let's continue. We have some more problems to work. So big two, some examples. So let's start with, let's say little a will be number 6. So let's see, what does that say? Do the exponential expressions represent growth or decay? And that's 0.22 times 0.04 to the t. Well, remember, so this is growth or decay. There's your question. So the answer is found right in here, the growth factor. So remember, if 0 is less than b is less than 1, this means decay. And if b is greater than 1, that means growth. So here 0.04 is obviously between 0 and 1, so this is decay. Easy peasy. All right, what about number 8? Number 8 says, give the growth factor that corresponds to the given growth rate. So we're told R equals 215% growth. So remember from your notes that B equals 1 plus R, but we want R to be written as a decimal. So here R equals 2.15. So then that's going to mean B is 1 plus 2.15, and we get 3.15. Boom. Easy peasy. All right, how about number 13? Give the growth rate that corresponds to the given growth factor. So here we're told B equals 0.27. All right, and recall that R equals B minus 1. So here R will be 0.27 minus 1. And then we grab our calculator if you don't know it off the top of your head, and I'm drawing a blank. So that should be what, 73 or 0.73, I believe. So minus 1 minus 0.73. So what we can say is R equals 73% decay. All right, so when it's negative, well, when it's negative, yeah, that's going to make it decay. All right, so then what about, let's see, how about number 15? Let's see, number 15. Q equals 200 times 1.031 to the t. All right, and what do we want? It says state the starting value A, the growth factor B, and the percent growth rate R. Okay, well, A is 200, B is 1.031. Those are easy, but then we got to find R. And remember, R is B minus 1. So that's going to be 1.031 minus 1. So R equals 0.031, which is positive. So R is 3.1% growth. All right, so keep in mind, when R is negative, that's decay. When R says decay, that means B is between 0 and 1. When R is positive, that means growth. So B had to be bigger than 1. All right, so try to keep those couple things straight. All right, so how about, let's see, number 26. What letter is that? Little e. Little e. All right, number 26 says, write an expression representing the quantity. So we're told the quantity of pollutant remaining in the lake if it is removed at 2% a year for 5 years. Okay, so we want to write this as an exponential expression. Okay, so let's see. So we'll say Q is going to be the quantity remaining. And we're not told an initial value, so we'll use the notation Q sub 0 is the initial amount. And that's just the standard thing to do. You always use subscript of 0 to represent your initial. All right, so then we can say that we'll have Q equals Q sub 0 times B to the T. So we have to figure out B. So what we need to do is find our rate. Well, we're removing at 2%. So we say R equals 2%, and since we're removing it, that's decay. So that means the numerical value of R is negative 0.02. So that means our B value is going to be 1 plus negative 0.02, which is 0.98. All right, so that means we get Q sub 0 times 0.98 to the T. Oop. But then we're told it's for 5 years, so what we do is we replace the T with 5. Oh, in case y'all missed some of that. Q equals Q sub 0, 0.98 to the 5th. So that's the quantity remaining after the 5th year. All right, so how about, how about number 38? Number 38. Let's see, here we state the starting value A, the growth factor, and the percentage growth rate for the exponential problem. So this is just one of those that it takes some work. Q equals 210 divided by 3 times 2 to the T. All right, so we have to break this up a good bit. So what you might want to do is break it up into the constants and the variable term. All right, well, 210 divides 3 nicely, or is divided by 3 nicely, excuse me. And then what we want to do here is write it like this. This is 1/2 to the T. Because remember, 1 to the T is simply 1. So I can use this notation in place of the 1 here, and then use the quotient to a power rule to break that off. And I'm done. So A is 7/10, B is 1/2, and that means R is negative 1/2, or R equals 50% decay. And that looks like just about everything we need to cover. So here's your second portion of 10-2. So enjoy these problems, and I'll see y'all on Monday.